Hi everyone, I welcome you all to the another episode from K21 Academy, where we take you in a journey from complete beginner to a certified professional. In this episode, we will look into what is AWS Load Balancer and how does it works. Let's look into the video and don't miss the ending for a special free class.
Understanding about the load balancer, getting in touch with the auto scaling concept, and understanding about the DNS over the clouds. So, load balancer, auto scaling, and DNS. This is what we are going to understand in this. So, the load balancer thing. Let us understand first what the load balancer is basically before we deploy it on the cloud. So, the load balancer is basically the one which can distribute and manage the incoming traffic, the traffic which is coming from the clients. It can distribute and manage this traffic across several devices like this so as to improve the performance for the clients. If I am having only one single server over here, then what will happen if in case my server 1 goes down, if all of them were hitting to the server number 1 directly and there was no load balancer in between. In a situation if the server number 1 fails, then what will happen? All my clients will get disrupted, their services will be stopped. With the help of the load balancer, the traffic doesn't goes to the server directly. The traffic is received by the load balancer, and load balancer will have multiple instances running behind the load balancer. Like suppose say if there is an web server, the replica of the web server will be created one, and there will be one web server and second web server, and both of them will be the replica of each other. So the user will not have any visibility where he is landing up, whether he is getting landed up to the server 1 or to the server 2, because both of them are exact replica of each other. But the benefit that we get out of it, if my web server 1 fails, then all my user requests will be diverted towards my web server 2, and my client will not get interrupted. At the time when both of them are running, then my performance is high. If one goes down, then I am functional via the other. So my availability has been improved, right? So that is what the main purpose of the load balancer is. Amazon also gives you the load balancers of different types. Amazon gives you application load balancer, network load balancer, gateway load balancer. Different types of load balancers are there for different purposes. And these load balancers helps the user requests to get spreaded across multiple downstream instances. So your servers which you have created are actually hidden behind the load balancer. There will be a URL of the load balancer which will be basically accessed by the users. The users will hit the URL of the load balancer. They will have no visibility towards the servers which are behind the scenes. And it will be the load balancer which will be communicating with the servers, the downstream instances. And this load balancer will keep on monitoring the instances, whether they are into healthy state or not. If they are not into healthy state, then it will suppose say the services on the server number 1 are not functional properly. So it will remove this server number 1 from the list, and all the user requests will be now forwarded to either 1 or to server 2. Nothing will go to the server 1. The 2 and 3 will take the whole load. As the server number 1 again come back to the service, again the request will start flowing to him. So the load balancer basically maintains and do the regular health check for the instances. If the health check fails, the load balancer will stop sending the request to the server so that the client should not get impacted. The load balancer can even enforce the stickiness. Like what happens usually is, if you have got three servers and thousands of users are coming to your website, load balancer will basically distribute the traffic between these three servers. Thousand of users are coming. Now, out of this thousand users, this user number one, first time when he came to the load balancer, the request was basically forwarded to server number one. In the background, this server number one did the authentication, authenticated the user. The user is now an authenticated user and was doing some task. But second time when the request came to the load balancer, if the stickiness is not enabled, then the request may land up for the same user, it may land up on a different machine. So for this machine, the user is not authenticated user. So again, it will initiate the authentication. Once the user is authenticated, then he will be able to perform the action. So on the load balancer, you can even enforce the stickiness, so that if the user has been once sent to server number one, till the time my server number one is healthy, all the requests which are coming from this specific user should be forwarded to the server number one only. They should not be sent to the server number two or three. So, like this, you can enable the stickiness on the sessions. Now, this load balancers can distribute the traffic among the machines which are sitting into different availability zones. If we talk about Mumbai, then one machine is in US East 1A, another in US East 1B, oh sorry, AP South 1A, AP South 1B, AP South 1C. The load balancer can distribute the traffic between the machines which are in the same region where your load balancer is residing. So it can span the traffic across multiple availability zones of the region where the load balancer has been created. You can deploy the load balancer in two ways: internet load balancer and intranet load balancer. That means internet load balancer is nothing but a load balancer which will receive the traffic from the internet. That is a public traffic. Intranet load balancer is a load balancer which will receive only the traffic from the internal network. So the private traffic which is handled by the intranet load balancer will have only private IPs associated with the load balancer. There will not be any public IP onto it. But with the internet load balancer, there will be a public IP which will be associated to the load balancer. So we can create both the types of load balancers, whatever we require: internet load balancer or intranet load balancer. Okay. So if I move on to my live page, if I go to the dashboard of NV, you'll be able to see that I have got one server running, and this one is my Windows machine. Suppose say if I create a pink colored website onto this server and I'm naming it as pink. Let's do that. So let me connect it to the machine. I am taking the RDP of the machine. So first of all, I will decrypt the password by providing the PEM file, and I will get the password. So I'll download the remote desktop file and will connect to it. I'm going a little fast on that because we have done it many times and I expect you to be proficient with that. So now my machine got connected. Now this one, suppose say this one is my web server which I have created for my client. So we will do some basic web server settings onto it, the basic settings which we have learned, and then we will put it behind the load balance. In the meantime, when the machine is up and running, let's go back to the whiteboard and try to pictorially understand where what is sitting. So again, if this is my VPC, if this is my VPC and this is my subnet, because I'm using only application subnet, so I will name it as application primary, and this one is my application secondary. You know that application secondary has been created in US East 1A, 1B, and application primary has been created in US East 1A. You are already aware about it. When we created the VPC at that time, we have done it. So these are the two subnets which we created. Right now, this particular EC2 instance of mine, if you notice, it has been created in application primary subnet. That means it has been created over here. Now you know that because this is an EC2 instance which is in my primary subnet, application primary, it has got a public IP and it has got a private IP. So this one is the public IP for my machine and this is the private IP for my machine. If I am trying to take the RDP, I will be using the public IP. Otherwise, I can use the private IP over here. We have got a security group which is created inside the VPC. This security group is SG for Windows, which we have used for our this EC2 instance, which is actually associated with it. And on this, we have created the rules to allow 3389, 80, 4096, and 22 port number. These are few port numbers which we have allowed onto this security group. Okay, this is what we have created. Now we got connected to the machine, and on this machine, we will quickly do the installation of the web server. From this page, I need to select add roles and feature. Once my server is fully ready to respond me, I'll be able to get this wizard. And then if I click on next, 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 and I will come to this server roles. Over here, I will choose web server IIS. I'll click on add features. So my web server has been enabled, and then I will finish the wizard by clicking on next, 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 and install. That's it. A basic web server has been created. I can close down this window because closing the window will not impact the installation of the service. I can see it from here that the feature installation is running over here. Once the installation is done, I will be able to go and create a desired colored web page onto it. If I minimize the screen, while the feature is getting installed, there is a folder called inetpub which is getting created. So I'll open that folder. Inside it, I am having a folder called www root and there is a file iis start. This is basically the landing page of the web server. So I'm going to open this in Notepad and I will delete all the content which is already there and will paste my content over here, which is a very simple application web server one. So the content has been changed for the file. Now, if I copy the public IP of the server and if I paste it in the browser bar, I will be able to see that pink colored web page over here. Now I will launch one more server which is an exact replica of my pink server. How can I launch a server which is an exact replica of my pink server? I can achieve it by creating an image of this server and then launching a server out of the image. If I want exact replica of this server, I will create an image of this server and then I will launch the server out of that image. So how can I create an image of this server? I will select the server for whom I want to create an image for and then I'll click on action, image and template, create image. As per the best practices, if your server is a server where the data is getting changed continuously, in that case, you should stop the server and then create the image. But our website is a static website. The content is not getting changed dynamically on it. Neither I am updating it again and again. So I can create the image of the server without shutting it down. Otherwise, you should shut down, that is, you should stop the instance and then you should create an image out of it. So I'll give the name of the image as K21 server img. While the image is getting created, by default, the system will get rebooted. If you don't want the machine to get rebooted at the time of creating the image, you can enable this option. Otherwise, you can keep it there. I'm going to enable it. So all the 30 GB of storage which was there with the machine will get replicated, and then I'm just clicking on create image. So what's happening basically when I'm creating image, eventually I'm creating an AMI, Amazon machine image. See, this is the same name I gave. And you are able to see the progress of this AMI getting created. Right now it is in pending state. Whenever you create an AMI, basically there is a snapshot which gets associated with it. You can see it under the storage tab. You'll be able to see it soon. In fact, if you go down in the snapshots, you'll be able to see the snapshot here. See, earlier we have deleted all the snapshots. Now this again new one is getting created, and it is getting created because I have created an AMI with this number 183F. If you go to the AMI tab, it is the same AMI ID which I have created. So basically this snapshot is the snapshot of the 30 GB volume which was there on the instance. Once my AMI has been created, if you click on the AMI, you'll be able to see the status over here, how much is completed. Once the AMI has been created, if you launch an instance from this AMI by clicking over here, or by selecting it from here and clicking on launch instance AMI, or in fact by standard launch ways by clicking on launch instance. While selecting the AMI, now rather than selecting the default AMIs, click on my AMIs. And over here you will be able to see this K21 server IMG. Don't do it right now. Wait for the AMI to become available. If you see, the visibility of this AMI is private, that means only you will be able to see it. But if you want to change the privacy settings of your AMI, then you can select the AMI in the metadata section, click on the permissions and click on edit AMI permission. From here, you can either make it public or you can make it available to the selected accounts, not to all. Currently it is private, but you can always go and can edit the permission settings of your AMI. It takes little bit of time for getting this AMIs created. So if you want to get a server launched from the image of your current server, then you need to wait for that much time. Because what now we have done is we created one server, we created an image of this server, and out of that image I will launch one more machine, and then I will create the load balancer, and I will make sure that my users are now not hitting the server directly. They will hit load balancer, and the load balancer will distribute the traffic between the machines. By default, when you create the AMI, it is private. What you need to do is, first you need to create a target group. This target group is nothing but a group of servers on which your traffic will be distributed. So you will click on create target group. This target group is a group of instances. The name of the target group is K21 web servers, which will be when somebody will hit on port number 80, the K21 web servers will respond. The servers which will respond are sitting in K21 VPC. That's it. I'll click on next. Which servers are there? Right now I have got only one server. So I will select that server and will include it as pending below. We'll click on this. Include as pending below. So right now I was only having one server. So I added only one server to the target group. When I will get the another one, I will add that one also. I will go to the load balancers and I will create one for myself. We will go into the details of what these types are in our next session. And for now, I will quickly select the application load balancer from the list. I will name it as K21 ELB. It will be an internet facing load balancer which is sitting inside the K21 VPC, and the machines will be in US East 1A and US East 1B, in application subnet primary and in application subnet secondary. This is what I selected. Then there is a security group which is required to be associated with the load balancer. So I can create a new security group by clicking onto this option at the console screen, and I can create a fresh security group, ELB, Elastic Load Balancer Security Group, which is the member of K21NV, and the rule is allow HTTP traffic from everywhere, nothing else, only HTTP. So I created the security group. I came back to my load balancer page. I'll refresh it. I'll remove this security group which got created, which got selected by default, and I will give ELBSG as the security group for the load balancer. And then I will say if the load balancer receives a traffic on port number 80, that means the load balancer listens the traffic at port number 80, then forward the traffic to K21 web servers. That's it. My load balancer got created. So simple. Within few minutes, my load balancer is there. So I created the target group. I created the load balancer. I already have one machine up and running. My AMI creation was in progress. If I refresh, now my AMI is available. So once it is available, I can launch a instance using this AMI. So I will create web server 2. So now I don't have to select the AMI because the AMI has been chosen by default. I will just choose the instance type, the key pair which I require, in which network will it be launched. So I said K21 VPC in the application subnet secondary. Give an public IP to this machine. For the security group, take up SG for Windows. That's it. I will launch the instance. Now I am launching the instance out of the AMI. So you know what will happen by default. Web server is now installed on it and a pink color page has been created on it. I don't have to go and create a pink colored page onto it because it was created out of the AMI of the pink server. That's why already the pink color web page will be there on it. If I copy the public IP, if I paste it in the browser, once my server is up and running, I'll be able to see the pink page. Right now, it is too early to see that. The only limitation with the AMI is, especially for the Windows Server AMI, the default administrator username and the password. The password will remain same which was there for my primary server. So whatever password was there for my pink server, this one will be functional for my web server 2 also. It will be functional for my web server 2 also. So basically the machines which you are creating out of the AMI, you cannot get the password decrypted for your default administrator password. So if you want, you have to keep it at a secure place. Although putting it into tags is not at all recommended in the production environment because tags are unencrypted. So don't keep it over there. I'm just keeping it because mine is an learning environment. So I kept the password over here. Because this web server too, you cannot decrypt the password for it. Even if the machine is functional over HTTP, you'll be able to see the pink color page. See, 34.226.215.47. This was the new machine that we created, and the pink color page is there on it. But still, if you will go and try to decrypt the password, it will not allow you. The instance was launched from the custom AMI, and the default password has been the default password has been changed. So the password cannot be retrieved for this instance. So you have to preserve the password. Okay, that is what you have to do. So I have preserved it. I already have the password for this web server too. So if I want, I can open the Windows R MSTSC and I will open the public IP of the second machine in the browser. Give the username as administrator and password as what we have copied, and connect to the second machine also. You'll be able to see it. So what I'm going to do is, technically both the servers are replicas of each other, but as I want to see that I am landing on different servers via the load balancer, so I will change the color to blue on the server number 2, so that you are able to see the difference when you are landing upon different pages. So this is my server number 2, which I want to be blue. Okay, this is the server. So I'll simply open the file explorer. I don't have to do the installation for the web server because it's already there. So I will simply open the file IIS start in the notepad and instead of pink, I will mark the color as turquoise, which will be a pleasant blue. So now if you hit the web application server 2, you will get a turquoise color page. So one server is pink, one server is blue.
Thank you so much for staying with us till the end of the video. I have something special to share. If you loved our content today, then you are absolutely going to adore what's coming next. We have a free class, and the best part is it's available for everyone. This class goes into the depth into the topics we touched on today, offering you detailed insights, comprehensive explanation, and some exclusive content that wasn't covered in the video. All you have to do is just click in the link in the description below and you will be redirected to this page. And if you are just starting out, just type k21academy.com/AWS02. Now, all the information inside the video that we will be covering is listed here. Now for the class, all you have to do is just select the event date, enter your name, enter your email ID, enter your phone number, and then click register now. Then you will be redirected to this page, and you can also add this to your Google Calendar. Also, I promise this is something that you don't want to miss. So go ahead, click on the link and step into the fold where learning knows no boundaries. Till then, keep enjoying. I will see you in the next video.